In 1981, a legendary physicist who'd helped create the atomic bomb addressed a small conference near Boston. Richard Feynman introduced his topic, the future of computing, by suggesting attendees turn conventional wisdom on its head. Rather than use a standard computer to uncover the universe's secrets, he suggested inventing a new type of machine, powered by the very principle it would study. Nature isn't classical, damn it, he said. If you want to make a simulation of nature, you better make it quantum mechanical. And it's a wonderful problem because it doesn't look so easy. More than 40 years on, efforts to build a useful quantum computer continue. But, as we're about to hear, one of our holdings could be the first to succeed. Welcome to Short Briefings on Long-Term Thinking. I'm Leo Kellion, and I'm joined by Luke Ward. He's an investment manager in Baillie Gifford's private companies team, and has recently been promoted to co-manager of the Edinburgh Worldwide Investment Trust, or EWIT for short. In this episode, we're spotlighting 3 private companies that could change the course of human progress. But first, a reminder. As with all investments, your capital's at risk and your income is not guaranteed. Luke, welcome to the podcast.
Thanks, Leo. Good to be here.
So we've got a big task today, Luke. We've got quantum computing, we've got space travel, and nuclear fusion all to explain. But before we start on that, can you tell us a little bit about how you got involved in investing? Because I believe you trained as a mechanical engineer.
Yeah, that's right. The thing which drew me to engineering in the first place was that it is the application of physics, so applied physics. How are the laws of nature going to impact the kinds of products which you can make? I think investing is a natural extension of that. It's the application of engineering. How can we apply these tools, these products which we create to improving people's lives, generating value, pushing the economy forward? So I think there was a natural progression of how do you get closer and closer to what's actually going to change things or influence the future.
And do you think that training gives you an advantage when you speak to some of the companies that you're looking at investing in?
I wouldn't overrate it too much, but I think it helps to have an ability to speak a similar language. If you're talking to an engineering founder or talking about the product itself, being on the same wavelength around the principles which it uses definitely help have that conversation. But I don't think that puts you a massive advantage over anybody else. There's lots of resources you can use to educate yourselves on these kind of things.
So your focus at EWIT and beyond is increasingly on private companies. Is there a particular type or characteristic that you look for?
We're looking for the same thing regardless of whether a company is public or private, and particularly in our context for EWIT. Is there a technological innovation that is informing a business innovation? It's all well and good for a company to have a product which is really compelling and sounds really cool, but unless it's affordable or unless it's easy to distribute, it's not going to have the impact that people hope it will. And it's not going to be able to create the value that it should. And so we're trying to find companies which can link those two aspects together such that they're one and the same. And that's often what creates a longer term, more durable edge around those businesses.
So Luke, let's start with quantum computing. And in simple terms, what is it and how does it differ from the classical computing that our listeners will be familiar with?
Computers in general are really useful because they allow us to simulate things without actually having to go and make them ourselves. We can do a lot of simulation in a computer at a much quicker pace and for a lower cost than we could do in the physical world. Think about how easy it is to make a plane today than it was previously. You can do a lot more of that in a computer rather than having to physically build and test the aircraft, for example. That analogy spreads to many other industries. Think of biotechnology as a good example for simulating drugs. But there are a class of problems where the complexity of that simulation increases exponentially. So even as you throw more and more computing power at it, even the world's largest supercomputers struggle to accurately simulate even the most simple molecules. And that's because the nature of those problems is quantum mechanical. It involves a probabilistic approach to problem solving rather than a classical, defined approach to problem solving. So that's where the Feynman quote comes from, is we need to have a computer that operates on those same quantum mechanical principles in order to properly simulate them.
So can you give me a real-world example of a problem that a quantum computer might be able to solve that we can't do at the moment?
Very specifically, there is a bacteria in the soil which takes nitrogen out of the atmosphere and turns it into the equivalent of fertilizer. It's how a lot of biology is based, keeping the ecosystem alive. But we don't understand exactly how that catalytic molecule inside that bacteria works. And because of that, we've had to create this normal chemical industry around a chemical rather than biological approach to producing fertilizer. It takes up an enormous amount of energy. It's $100 billion, market per year just for producing this commodity. If we were able to interrogate that catalyst with a quantum computer, we would understand precisely how it takes the nitrogen out of the atmosphere and fixes it into something more useful for plants. That would then allow us to copy that process and hopefully make a much more efficient way of producing fertilizer. So a quantum computer is the key to being able to do that. But one simulation, which you could run in a week, say, could have a $100 billion impact on the world economy.
So it could unlock huge amounts of value. And there's quite a number of companies who are trying to create a useful quantum computer. You've got Amazon, Google, Microsoft, to name but three. You've invested, though, in a smaller company that's taking a very different approach to the others. Can you tell us a bit about it?
What's been needed in quantum computing is a way to make the hardware scale. So it's relatively easy to produce a small quantum computer with a handful of qubits, which are the equivalent of transistors to solve the problems. But in order to really address these large, meaningful problems, you need to find a computer that can scale to the millions of qubits. That is much, much harder than going from sort of 1 to 10. Going from 1 to 1 million is to date been almost impossible. The computing company which we invest in called PsiQuantum has, we think, the most scalable approach. So rather than trying to take exotic hardware and figure out elaborate ways to make that scale, they've gone straight to the classical semiconductor industry. If we want to make 1 million of something at high yield, the best place or the best way we know to do that is in semiconductor manufacturing, to do it in silicon. Their approach is, why don't we take silicon manufacturing and figure out how to make that operate in a quantum mechanical way? That's very different to other approaches, which are taking exotic hardware and trying to figure out, one, how to make them scale, but two, how does the supply chain even exist around that?
And PsiQuantum's approach relies on photons, and that's to do with light, isn't it?
Their approach uses photons within the silicon. So the photons are what are carrying the information. They are famously hard to control and to program with information. But when they hold that information, they're very resilient to interference. And that has been the big challenge of scaling these computers. If you're using superconducting strings or trapped ions, for example, as other approaches do, you have to treat them in a very, very delicate manner. And when you've got thousands or millions of these operating very closely together, they start interfering with each other, and so the system breaks down. With photons, you don't have that problem. You can have millions of photons flying around these machines, and they won't interfere with each other.
So what gives you the confidence that PsiQuantum's approach is going to succeed?
I think they've been consistent in their approach over the past 15 years when they've worked in academia and now for the last couple of years as a company, in that we need to have a scalable approach to error correction within these computers. And to do that at scale requires a photonic approach and a silicon approach. Lots of the rest of the industry are now almost reluctantly coming around to that way of thinking as well. You're getting a lot of endorsement from their competitors now coming around to a similar philosophy about making a computer. But beyond that, in terms of their technology implementation, they've demonstrated, all the key components which they need on a circuit to be able to do this. And then thirdly, they've had a lot of endorsement from governments as well. In the course of the last year, the Australian government has contributed, I think it's about $620 million to an effort to produce a quantum computer, all anchored around the PsiQuantum approach in particular. So they're being paid to make one of these quantum computers in Brisbane in Australia. Secondly, DARPA, the Defense Advanced Research Product Agency in the US, has come around to this same way of thinking as well. They've spent the past 2 years trying to interrogate different quantum computing companies to figure out which approach might be the quickest to scale, because they're realizing the strategic implications and the need to get this before competing nations might. And they have put a lot of money into a site in Chicago, which again is being anchored around PsiQuantum's approach to try and generate one of these computers before the end of the decade.
So you say they might have this computer up and running by the early 2030s. Once they do that, what do? They rent it out to other companies and they start generating revenue from that?
These quantum computers will likely be plugged into the cloud and quite easily accessible from there. The question for us is, what does the business model look around that? If these computers are as powerful as we expect, they might be able to price them on a value basis rather than a volume basis, which is quite different to how computing has been sold previously. NVIDIA, for example, typically sells X number of chips at Y price and produces Z revenue. This company could go and say, okay, there's a biotech company which wants to try and produce a cure for this particular ailment. We'll partner with them rather than being a supplier to them, and we'll bring our expertise to help address this problem. And we might take X% of the overall value which that creates.
And what evidence have we seen so far that there are companies out there who want to use this?
There's many companies which they're partnering with which are still under NDA. There's some which have been announced in press releases. So Mitsubishi Chemical, for example, Mercedes-Benz working with them. Again, trying to quantify, if we had a reliable quantum computer today, could we use that to make a better battery material? Could we use that to make a better chemical for this particular production process? And working hand in hand with PsiQuantum to try and identify what are the improvements we need to make to our processes today so that they're suitable for a quantum world of the future.
So that's PsiQuantum and quantum computing. Let's move on to advanced rockets and SpaceX specifically. Baillie Gifford first invested in the business in 2018, some time before it became one of the world's most valuable private companies. For any listener who's maybe unfamiliar with what happened in the interim, Luke, can you give us a quick recap?
Again, a tech innovation linked with a business innovation. So it was very, very expensive to launch payloads into orbit before SpaceX came along. Their technology innovation was coming up with a reusable approach to rocketry. Rather than throwing the rocket away each time, is there a way to recover that hardware such that you can depreciate the cost rather than dispose of the cost over time? The more frequently you use these rockets, the cheaper and cheaper it should become to operate the business. So a business that can get better as it gets bigger. Whereas previously it was just the preserve of governments which could operate in space. Now, thanks to SpaceX, it's increasingly affordable for everyday businesses to operate hardware in space as well.
And they've also moved into Starlink, haven't they? Starting with letting people get their homes and businesses connected to the internet via satellite. But they've been expanding that into boats and aeroplanes, and I think they've even got a travel kit now so you can use it when you're camping. What's the growth case for the Starlink side of the business?
Starlink is their own satellite network, so the rationale being here, if we have an innovation to get more payloads into orbit, why don't we start making those payloads as well? And if we have the rockets that are able to deliver them, we'll be in a more advantageous place than others to provide that service. So SpaceX are now producing these Starlink satellites. I think there's around either 6,000 or 7,000 of them maybe now in orbit around the planet, all designed to provide a broadband signal regardless of location. So again, this technology innovation leading to a business innovation, the business innovation being there's probably 3 billion consumers out there that don't have reliable access to the internet. With this innovation, we're able to provide that in a way that no one else has been able to previously. Over time, as that network grows, it gets more and more affordable to deliver that signal. Connecting the incremental customer is very, very cheap, as opposed to a terrestrial network where it's very expensive to run a new cable out to a house in the middle of nowhere, for example.
And if they can keep shrinking the antennas down, I presume that they can get it out to more places as well. Where's the end game with that?
So one of the problems of connecting your mobile phone to a satellite is that it's a very, very long distance and the antenna in the phone itself is very, very small. So you need a really high power signal in space to be able to reach a telephone or a SIM card on the planet, for example. So previously, too expensive to install a satellite with that level of power. Whereas now, because of the rocket innovation, but also because of the learnings from the satellite network, the next generation of satellites they're building are going to have payloads which do have that level of power, because it's cheap enough and affordable enough to place that into orbit now. And so one of the exciting things for us from the investment case is, I think it's probably properly coming online next year, but there's some markets been opened up now, is that there won't be a place on Earth where there isn't a mobile phone signal anymore. And so if you could connect every single handset, every single Internet of Things device to the internet permanently, the level of connectivity you can embed in everyday products and the increased value you could offer individuals on the ground from that is really, really compelling and can be provided in a high margin way as well.
So that sounds like a huge growth opportunity. But For SpaceX, all of these are stepping stones to its greater, grander mission, which it says is to get humanity to Mars and make us an interplanetary species. Does that figure into your investment case, or is that too long-term even for us?
I think it's probably quite an important part of the investment case. I think to most other people would hear that and think you're absolutely mad to be, investing in a business that's got this stated aim of this goal to demonstrate something which doesn't have an immediate commercial value of, yes, we can put a flag on Mars, but how does that help people back here on Earth? It's a totally valid question to ask. Tangentially, it's really useful for the business, first and foremost, because that's how you attract the best people in the world to come and work for you. If you have this stretching goal, this significance which you contribute towards, that is something which not every single company is able to offer. And so beyond a salary, that gives you a competitive advantage in hiring the best people in the world. But also, SpaceX know that in order to reach Mars, they need to produce a rocket that is wildly more effective and efficient than the ones which we've had historically. And so all of the innovation that goes into a rocket like Starship to get to Mars can also be enjoyed in getting payloads into orbit. And there's only going to be a handful of these rockets which are going to go off to Mars. The majority of them are still going to be used on a fully reusable basis to get more and more commercial payloads into Earth. So I would sort of flip it on its head and say, rather than it being a goal to get to Mars, it's a goal to make space access 100, 1,000 times cheaper from where it is today. And when you think about the implications of that in an investment context or a commercial context, that's phenomenally powerful as a value generator of unlocking more and more applications on Earth and in orbit around Earth.
You led the investment into SpaceX. Indeed, you've led the investment into all the companies that we're talking about today. And as a private company, it gets to decide who it sells its stock to. So can you tell me, how did that original deal come about in 2018?
One of the benefits, I think, of working at Baillie Gifford, and one of the aspects I quite like about the job, is that we do have license to think about what technologies or what companies might influence the world over that 5 to 10 year period that might not be directly investable or directly relevant for our clients today. For some, that might be an indulgence of being able to sort of daydream about what the future might look like. But if you can start making small steps towards realizing those kind of investments today, it can really pay off in the future. In private companies in particular, with them choosing their shareholders, you need to be able to demonstrate why your client's capital is more valuable than someone else's and why they would want you to have a seat at the table or being a long-term partner of theirs, where it's not something that you can change that very quickly. This is a real long-term commitment. So as part of that, it's important to get to know these companies many years in advance of actually making that investment. So whilst we invested in 2018, we'd been looking at space as an investable area for several years before that. Again, maybe the engineering helps a little bit there in that you can go to technical conferences, you can meet the actual engineers at these businesses, get to know them, appreciate where they are on this technology roadmap. How mature is this towards becoming an investable business for us versus this is still something that is going to be years in the lab or is something maybe for early stage venture capital instead. So with SpaceX, we took the opportunity to go to these conferences and meet some of the executives who are presenting there. So we went and met Gwyn Shotwell at a conference, talked about what their needs were over the coming years.
Gwyn Shotwell runs the company day-to-day.
So Gwyn Shotwell, being the president and COO, so again runs the business today, has been there for an awfully long time. And really is one of the most important people there, aside from Elon Musk. Again, on other investment trips where we'll be out seeing holdings in California, we made a point of stopping by their headquarters in Hawthorne, not with any particular agenda, but to try and build that relationship and evidence that, we could see the longer term vision which they're talking about and would be supportive of that. And more importantly, I suppose, see how the tech innovations tie into the business innovation and really appreciate that, the vertical integration of the business, which I think was not immediately apparent in the financial press, for example.
And by vertical integration, you basically mean just doing it all in-house?
Yes, that's right. And so over time, you build up that level of credibility. And then when it comes to them looking for more funding, that causes them to pick up the phone to you as opposed to someone else. And so we were lucky enough to be able to invest in 2018. And I think we were the largest investor in that round as a result.
The space industry's its potential seems almost limitless. Does that mean then that your investment in SpaceX means that you see us as being particularly well placed to make follow-up investments now?
Yes and no. I think we've made this investment in SpaceX for a long time because we think they're really pioneering and pushing what's possible in this industry. They're not just following along others. And so on the one hand, when we speak to SpaceX and we get these insights from them, it's easier for us to appreciate how their level of competence could compound over time rather than diminish, or how they could get better as they get bigger. In some ways, that makes us want to, buy more and more SpaceX or have that as a large holding. And it makes the bar for other space investments higher and higher over time. So we don't just want to have a broad exposure to this as a theme. We want to be choosing businesses rather than industries. And so the question we have for other space investments now is, how is this different to SpaceX, or how does this complement an investment in SpaceX, as opposed to, is it just it's operating in space and we like the notion of that and so therefore we'll invest? Those aren't the kind of things which we want to do with the client's capital.
So we've discussed SpaceX taking a stepping stone approach to its business, and there's another firm that you've invested in that's taking a similar path to trying to achieve nuclear fusion. Before we get into the specifics of how it's doing that, can you explain what nuclear fusion is and how it differs from the nuclear power plants we have today?
Nuclear power comes from either splitting or joining together atoms. Large, heavy atoms like uranium want to naturally fall apart, and when they do, they release energy. Lighter atoms like hydrogen, when you squish them together, they can form larger atoms, and in the process, they release energy too. So fusion is what happens in the sun and in all stars. The gravitational forces there are squeezing these atoms together and causing them to release energy in the process. The reason why fusion is interesting is because you aren't dealing with the same kind of radioactive waste or radioactive risks that you are with uranium and plutonium, etc. And in theory, the fuel, it might be more readily available as well. And so the prize there is potentially a cleaner, high power source. The problem is saying we're going to take the sun, miniaturize it, and keep it in a little bottle in a power plant. That's an enormously complex thing to do, and we haven't been able to do it that successfully to date. There's some gargantuan lab experiments which have been able to contain a fusion plasma for a handful of seconds and generate a tiny amount of power, but nowhere near the level of competence which would generate a break-even power for us to get more electricity out of it than we put in. And so that's the goal with fusion energy, is to try and create a device that is capable enough and more importantly, cheap enough so that fusion can be an economic pursuit.
So who is it that you've invested in, and what's their approach to it?
We've invested in one company in this area called Shine Technologies. And the reason why we find this one in particular appealing is they're not trying to leap straight to energy generation, which is probably one of the most demanding and complex things you could do with a fusion reaction. At a lower power level, the fusion reaction can be used for other non-energy purposes. So one of those, for example, is to use the neutron particles that fly off to do imaging of lightweight materials like carbon composites. They're really hard to image in the same way with X-rays, which we would use for conventionally items like steel or construction equipment. When you're looking at a wing or something made out of carbon fiber, it's hard to find defects in using other methodologies. So there's a really compelling business case around using their lower power fusion technology as the neutron source to image these composites.
So you start with imaging. What's the next stepping stone from there?
If they can make enough money out of imaging, which they are doing at the moment, they can reinvest that into improving their fusion technology to a slightly higher power level. And when you can get a neutron flux at that higher power level, that unlocks a new problem for them to solve. Producing radiopharmaceuticals is a really exciting application here. They have a technology which can create pharmaceutical products which sell for about $1 billion a gram.
Wow.
So this is incredibly valuable, but importantly, a low volume application. You don't have to create this enormous, machine in order to do this. The equipment is actually quite small, albeit complex. These isotopes, like lutetium, for example, in more recent clinical trials has been found to cure some instances of prostate cancer. It's like having little smart bombs that can go around and identify exactly where the cancer is and then deliver these tiny radioactive payloads, as opposed to just washing the body with radiation externally or chemotherapy, which can be quite non-discriminate. This is really precise.
And are patients already using medicines made by Shine Technologies?
Yeah, so because Shine has stood up the supply chain, there's lots of clinical trials being able to access this, which wouldn't otherwise. And so it's one of the nice things about investing in a company where it's directly improving the outcomes for patients here. but also using that money which they create to reinvest in more and more products rather than just sitting on their laurels.
And then what comes next after that?
Sure. So if $1 billion per gram isn't impressive enough, the notion of recycling nuclear waste is the next problem they could solve. Governments around the world have been using legacy fission energy and creating a waste liability as a result. I think the US government has about a $45 billion waste liability of how do they dispose of this nuclear fuel. If you can irradiate that with sufficient neutrons, you can start recycling that fuel. You could take rare earth minerals out of that. You could take particular isotopes out of it. But you also wouldn't have to worry about disposing of that for a millennia-long period. You could manage it in a much shorter time frame. Even before we start thinking about energy, there's an enormous amount of value we could create with fusion rather than just generating electrons.
So all three of the companies that we've talked about are private. And for the man or woman on the UK street, it's not easy to invest in these companies. And one way of doing so is via a trust like EWIT. We're recording this at a time when a activist investor is trying to change EWIT's purpose. So can I ask you, why do you think it's so important that the public still is able to invest in companies like these in this way?
To take a step back, I think one of the most reliable forces in the economy and generators of wealth over long-term time periods is technological innovation being harnessed by entrepreneurs and companies to create products that are valuable for consumers, businesses, governments, etc. That's probably one of the most resilient investment themes in which you can invest in. So when we started up the mandate for Edinburgh Worldwide, we explicitly wanted to focus on young entrepreneurial companies, which we think are shaping the future and will become those big winners over time. One of the dynamics we've seen in equity markets over the past sort of 10, 15, 20 years is increasingly there are quite a few of those ambitious companies staying private for longer. Whereas previously they might have been accessible to our clients in the listed market, now they might be private until they become much larger. And so there's the potential for our clients to miss out from that explosive growth in that early stage or some of those inflection points, which has been much more the bread and butter of the portfolio historically. So we, along with the board, took the decision to try and complement the fund with an allocation towards private companies, specifically in areas where there isn't a public market access to it. So space is a really good example of that. Nuclear is a really good example of that. Quantum is a really good example of that. There haven't been that many young businesses in the public markets which have been explicitly focused on those. They have been in the private markets. And so we seek to use that to complement our clients' ability to invest in that underlying human progress and the advancement of commercial success there.
And it would be remiss of me not to ask, are there other groundbreaking technologies that you're still trying to find an investable opportunity in?
Geothermal could be really interesting there for the future. This notion that geothermal power is available anywhere if you can drill deep enough. The challenge is we need a technological innovation to unlock that capability, to make it affordable to do that. But if you can do that, you can then have a business innovation as a utility company. You can take your legacy fossil fuel infrastructure, which is probably a liability for you at the moment, and repurpose it into a fully green asset, taking geothermal 500 degrees Celsius water and driving those turbines that way instead. That could lead to a revolution around the world in terms of power generation.
Well, that's fascinating, the idea of drilling for hot water. So, Luke, almost time to bring things to a close, but the last thing I like to do on this podcast is ask our guest what book they've recently read or what other source of inspiration they've drawn on. So what's been feeding your mind?
It's hard to find books on cutting-edge technology because they usually become out of date pretty soon afterwards. So one of the most rewarding things which I enjoy doing is going out to industry conferences, particularly over a number of years. So I'm just back from one in Silicon Valley, which I've been to previously. But it allows you to compare and contrast how the industry is changing over that time period. And that's something which would be quite hard to get access to otherwise, but I think is a really useful one because it informs how competitive advantage is changing. It's quite easy to see how a growth opportunity could be improving, but the edges and the nuances of the industry are a bit harder to penetrate unless you're actually there speaking to these people.
Luke, it's been fantastic speaking to you. Thank you so much for coming on the podcast.
Thanks for having me.
And I hope you enjoyed this conversation too. You can explore more about the companies Luke discussed through a number of articles he's written. including a recent infographic detailing quantum computing's potential uses and an interview he conducted with Shine Technologies' chief executive. If you haven't already done so, please do subscribe via Spotify or any podcast app to be among the first to know when our next episode is live, and you can search our archive, including write-ups of this and past shows and their transcripts, at baileygifford.com/podcasts. But for now, listeners, I look forward to briefing you again next time.